is Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada, here at my desk. We went to the Lunar New Year parade here in New York City, and we did some electronics. Let's talk about electronics. I did actually a bunch of hardware designs this week. I'm still getting over this cold, but that's okay. This week, what I worked on the most were some cowbells. I tend to go into little modes, and I'm like, I'm going to design a bunch of BFFs. I'm going to design a bunch of sensor breakouts. I'm going to design a bunch of feathers or whatever, but that this week was cowbells, and this is our lovely bell, the cow bell logo. So let's go quickly to my computer and I'll show off some cowbells so people can get reminded of what they are. So cowbells are boards that go with the Pico or the Pico W, and they add a bunch of functionality. So let's say you want to do data logging. So these boards are kind of thin because they fit basically right on top of the Raspberry Pi Pico. This one has a micro SD card, an RTC coin cell, and a stemma QT, and a little reset button over here. And then, I think in the guide, maybe we show, an assembly. You can put the cowbell underneath, or you can put it on top. But you do have to, solder headers. This is one example, stacking headers on, and then you can have the board go into the piece, solder breadboard, and then the Pico on top. So basically the Pico is very low cost. It's $4 or $6 or something. But there's other stuff you want to do with it, like add CAN bus support, or maybe this is a DVI output feather that adds the ability, the Pico can, using PIO, it can display graphics to a DVI monitor. This is a demo for that. So I designed 4, and then I had to take a break. I ended up doing a lot of more redesigns, but I did get started. I got this prototyping one, which is low cost. But the idea is that it's just prototyping area. But then, we had other ideas that I've been kicking around. So one thing is we've always had this wing shield, which is really popular because it's a really easy way to connect wires to an Arduino shield while you can stack a header on top, stack another shield on top. And so the first thing I designed was a Picowbell. Hold on, I gotta find this. Okay, so I did the proto, so the terminal bell, and this is a rendering. So I thought because I always think it's hard to see from the EagleCAD exactly what's up. We use 0.1 inch header, and so this actually ends up fitting, nicely on top of a Pico, and it has the same prototyping area. But I just sort of extended the board out and then put 0.1 inch terminal blocks. So unlike 3.5 inch terminal blocks, 0.1 inch terminal blocks don't snap together. They do fit, they're almost but not quite 0.1 inch long. So there's a little bit, you can see here, there's a little bit of a neep, neep, this goes neep, and that one goes neep, just 10 mils or whatever, either direction, to make room for either side, because they don't, like I said, unlike the 3.5 millimeter, the 2.54 millimeter 0.1 inch terminal headers don't snap together. And if you're curious, 10 pin 2.54, I think. Yeah, so this is the connector I'm using. So you can see it's 10. They don't make them in 20. 10 is the maximum. So you just have to put one after the other. So that's the first one I made. So that's going to come with the terminal blocks already on and stuff. And then this rendering, and then you can use stacking headers or socket headers. But it's kind of nice because then you have support typing area, and then you can wire up anything you want. And this goes to each pin. So it's 1-to-1. So it's nice. And then let me see, I think the back. Yeah, I have all the pins labeled on the back nicely too, so you can quickly tell what are you connecting to. So then I was like, okay, another thing I wanted to do is, we have the Memento camera, and I've been doing a lot more camera projects. We added, they have the OV5640 camera breakout. These are a pain to wire to boards. So for example, if you're wiring this to it's a Pico camera, I think. If you're wiring this to a Raspberry Pi Pico, it's just kind of a nightmare to like wire. There's just so many pins because you need like 8 data pins and then VSync, HSync, P clock, X clock, power down, enable, I don't know, enable, whatever. There's like a bunch of pins. So to make that a little simpler, and because the RP2040 has, you know, enough RAM to do like, you know, fairly enough pins, and it can do PIO, it can actually interface with these parallel interface camera modules. And I thought, you know, especially with the Pico W, you could then do like internet camera types of projects for cheap. And so this is a camera board version. So there's the camera module in the middle here. It plugs in and it uses a very slim FPC connector. And you can see it just like, it just fits quite nicely. Turn off the bottom there so you can see it clear. And then this is a micro SD card, same as the Ada logger. And then they have a couple of components. There's a reset switch here, which I think won't be in the way of the camera. I think it'll be fine. And then there's a bunch of power supply stuff because these cameras use 2.8 and 1.5 volts. And then a little button. This is like actually not a reset button. This is a shutter button. I connected it to like pin 22. And so I think like if you have a camera, you want to have like a little button to like take a photo or whatever. And then a STEMMA QT port. So I thought that'd be fun because I got all these camera modules and I was like, oh, well, we can make a cowbell so people can do camera projects with the Pico or Pico W. And then I was like, oh, to make it easier to like do some of this prototyping, we have the proto plate, but I thought it would be also good to do like what I call like an underplate. If you go to the overhead real fast. So one of the things I use when I prototype feather stuff is I have these feather doublers and triplers and quadruplers where you can connect them side by side and they're wired through. So each socket is duplicated. They're all connected together. So you can have multiple, like, of course, like the one thing I didn't, like a feather here maybe. Okay, so I have like a feather wing, you know, here, this like TFT feather wing. And then like, you know, pretend that this has a header on it. And then I can connect it here. And then like I connect 2 more feathers. And as long as there's no pin, you know, conflicts, that'll work. So I wanted to start with just a single. So can you go back to the computer? The reason that I'm having a single is because this is going to use 2x20 like socket headers. And so if you have the Pico H or the Pico WH, which are like, they have the headers pre-soldered in, this is like, you can just plug it in directly. And so that can be kind of nice if you just want to like, especially if you just want the reset and STEMMA QT port, you don't even care about the proto. It's like, boom, you don't even have to do any soldering. And it's like nice and slim. So this has all the pins labeled, 4 mounting holes, 2x20. And that means also when you plug it in, you'll have 2 more headers on the opposite of each side. So actually, can you go to the overhead again? Sorry, I forgot to show. So this is like I use a similar setup on this this brains board, and you can see you can kind of see there's like 1 row of header exposed because this is a double header. And I like the double header more than the single because I find that it's more mechanically stable. It's like wide enough. They do make 1 single row header, but I find it like bends, it kind of bends and breaks so easily. So I like the double, and like bonus, you get an extra row. It's not that much more expensive. It's about the same price. Okay, so let's go to the computer. We'll get through this. We'll wrap it up. We'll go to the great search. So this is the single. And it was like, okay, so I just took the proto and then like I just like widened it, add the row of double headers. So this will be nice, just super great for quick debugging and prototyping. And then of course, if you have 1, you're like, well, I want 2 because I want to have maybe like the Pico and then like, you know, a bell. So I made a doubler. And this is the rendering of the doubler. So this is the same as the last one, right? You've got the reset button and the STEMMA QT port. And then I like cloned it, like clone tool, except not really. In EagleCAD, I just like duplicated the work. But I don't want to have 2 reset switches and 2 STEMMA QT ports. It doesn't make any sense. So I was like, oh, well, let's add an enable switch. So this connects to this enable pin here. And that'll shut off the 3.3 volt buck converter. So that might be handy if you want to like turn something off. And the reason especially I think that's extra useful is because it added a battery, LiPo battery and charger circuit. So this is 0402, so I have to go kind of small. But this is, there's 2 LEDs, one for like charge done and one is like charge state. And then the MCP 73831, some capacitors, and then a pass transistor. And the pass transistor is basically doing, this diode actually already exists on the Pico. So what that diode is like this plus this pull down. So like it's like this section here. And what that does is that when the USB is plugged in, it'll power from USB. And then when USB is not plugged in, it will charge, it'll connect the battery to the power input. And if you do it this way, it means that you don't end up like constantly charging and depleting your battery while on USB. Like the battery is completely disconnected from the load. It's only charged. So it's kind of nice. So it kind of ganked that from the Feather. And I even used the same like this super tiny PFET transistor, which has worked great. Loving it. So that's the doubler. And then I'm still working on the tripler because everyone's like, okay, like there's more. So you can see it's like in progress. Let me just pull it up real fast. So this is the tripler. No rendering yet. So you've got at the bottom the reset and stomach QT still. And then the middle, and then I forgot to mention on the back, there's like an adjustment for whether you want it to have high current. And also you can disconnect the charger. So if you want to like plug it in and power it from AA or AAA battery pack and you don't want to have the charging circuit, when you cut this jumper, it disconnects the charger from the battery. So it's more advanced. But like I've actually started to try to do that a little bit more because sometimes people are like, oh, I don't want the charging circuit, but I do like the battery connector. And then let's see, this is top. And then over here, I think I'm going to add an iSpy connector, although it might be like a real pain in the ass to route. So I'm not going to do it if it's a total nightmare. But I could add an iSpy connector so people connect like displays really easily or like e-inks or whatever. And then I added a NeoPixel. I don't know. We'll see. This is, again, like still very, very much in progress. So that might, if this doesn't, obviously I have to remove these two pads, which is fine because I've got that broken out here and here. But like routing all these pins through might be kind of like, I mean, I think I can do it because I'm only using the bottom, but I don't know. Sometimes it doesn't work out. In progress. Okay. So that is the hardware I'm working on. So let's move on to the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every single week, Ladyada uses the power of engineering to help you, yes, you find all the things you want to find on digikey.com. Take it away.
Okay, and my hair is like DigiKey red, right?
Yeah.
Okay, so this week I worked on this design, which is a underboard for, an underboard for the Raspberry Pi Pico. And I was saying like, oh, I have a stomach QT connector and a reset button. So I2C resets easy. And then I have an enable switch. But I also wanted to add battery charging, especially for the Pico W, it's wireless. Maybe you want to have like a IoT thing that runs on a battery with battery charging. And so I kind of borrowed a circuit that I use for let me get rid of the sidebar. It's so big, especially in 720p. It's very noticeable. Okay, sorry. Okay. I borrowed the circuit that I use for the Feather boards, which uses an MCP 73831, has two LEDs, one for charging red, one green, which is like done. And then capacitors, you can set the charge rate with a resistor. And then there's like a pass transistor. But I realized I never actually covered LiPo chargers. And so even though I use this one, by the way, there are a lot of other options on DigiKey. But even this one has a lot of like, especially during the part shortage, you got to really watch out. Not all numbers are the same for this part. There's a lot of like dash XYZ that you might want to watch out for. So let's go to DigiKey. and search for battery charger. So what we want is a battery charger that will charge 3.7 nominal, 4.2 volt max batteries from USB, because that's what we're getting, like 5 volts in. And I want something inexpensive that can also, it doesn't require I2C to set up. It just is set by a resistor, because a lot of the really fancy chargers have like I2C, or they have 1Y or whatever. I don't want, where you can do all sorts of configuration and like also monitors the battery. I want something like cheap and easy. And again, resistor set. So you set the resistor, and then here I have my little guide that reminds me what you set it to in order to set the charge rate. And I'll be honest, actually, this says 1 amp. This charger actually can't do 1 amp, which we'll also talk about. There are some other chargers that can. So let's go here, and then we'll look for battery chargers. Okay. So there's like big battery chargers, there's battery management, but we want battery charging chips. So let's go here. So there's 3,000, there's quite a few. And they come from anything like DFN and SOCT to like, they can get a lot of pins and very complicated. They come in BGA also. So let's just try to pare down this massive number. We're only gonna look for the active items. And we're only gonna look for ones that can handle 1 cell, because there's some that do 2 or more, and then I'll pick up the dash as well. And then let's just we only want surface mount, and let's just say we only want in stock, so it's available to purchase now. Chip shortage is kind of over, so basically if it's in stock, that means it's gonna, if it's not in stock, it means it's probably like not available. And no marketplace, just because I don't want to have the double entries for externally sold parts. Okay. Next up, so the battery I'm using is a lithium ion / polymer battery. And there are other chemistries available, but pretty much, I'm going to pick up the dash just because who knows. Lithium ion and polymer. Lithium iron phosphate, I think, is something different. Multi-chemistry. I actually don't want any of the multi-chemistry ones because those are always going to be more expensive than just a dedicated charger. And then I want to also set the voltage of the, actually, I don't know if we can set the voltage. Well, let me do this. Let me just filter on the chemistry. Okay, good. So that's much chiller. Okay, so next up, charge current max. Well, I really feel like if I'm going to charge these batteries, it needs to be at least 200 milliamps. And, I can go higher. But honestly, like no charger that's going to be affordable is going to be over like 3 amps. And then the battery pack voltage, I want it to be for these batteries that we're using. So these are lipoly batteries. If you're using other batteries, go to town. But the ones I'm using, I think I actually call them lithium polymer, but oops, sorry. Great. These are 3.7 volt nominal, 4.2 volt max. And so watch out, because it's, even though it says 3.7 volts on the battery, you don't actually want 3.7 volts. You want like 4.2. So I'm going to pick also the ones that can do, whatever, but I definitely don't want the ones that do higher voltages. This is all I want, 4.2. And then interface, I actually don't want I2C or USB. I want something that is, again, a very simple interface. So just GPIO programmable. And this will reduce the number quite a bit. Yeah, now we're only getting like, okay, there's one or two one, two or three cells. Okay, now I think we're good. I mean, the voltage, I don't care as long as over 5. All of them are over 5. Current max, I think, is okay. So let's look at some of the options. So we've got the MCP 738 standard option, and they have a ton in stock. There's also the 832, but they have them also in DFN. But there are other families. I'll say the BQ series from TI, they're quite good. These are, they also have a charge LED. You can set the current with a resistor. Some of them have like termination timers, like how long you wait before you time out or whatever. They also have a power good output. So, the more pins you get, the more options you're going to get. And this also has a temperature reading, which I'll say, if you're charging at a higher, if you are going to have people with batteries that are charging at a very high rate, like 1C or above, it's not a bad idea to have a temperature monitor, especially in like a production product. For this board I'm making, it's very simple. It's like low cost, and the charge rate is already kind of set quite low, so I'm not worried about it. But a built-in thermistor battery pack is never a bad idea. So one thing I'll mention is the battery charger I use on that board, that design, does not have a thermistor built in. It's a good idea, especially if it's going to be used outdoors, because at very low and very high temperatures, you do have to change the charge rate. There's also ST has, a nice low cost battery charger. One thing that is nice about this one is it does up to 800 milliamps, which again, the charger I'm going to show does not do 800, and it's very simple. It just has like LED, program, power in, battery. It's like there's something quite nice about it. And I like that it has a little bit higher input supply voltage max, up to 10 volts. Not that you should use 10 volts, but like sometimes I've seen people like they plug in like some random off the shelf, USB power adapter, and it like kind of floats a little bit above 5 volts. And sometimes it can actually get popped. Kind of rare, but it does happen. One thing that I'll say that I've never seen is a battery charger chip that is reverse battery protected, which would be kind of cool, because I do one of the things and in this small package at a reasonable price, because I do see a lot of customers, we warn people like 8 billion times, do not buy batteries from Amazon that are the opposite polarity. And then people are like, I plugged in this battery that I bought from Amazon, and then I realized it's reverse polarity. Did I damage it? And I'm like, yeah, it's dead. Like it's like, but they're like, I unplugged it within like a minute, and I'm like, it's done within like 10 microseconds. You can't unplug it fast enough. That'd be cool. If anyone knows of a battery that does that, or a battery charger that does that, let me know. But this one is nice because it does 800 milliamps. But the one I tend to use is this. Get the part number quick. 73831, which is available in, it's kind of the one they have the most of. And there's a couple different ones in this family. Or first off, they have a DFN version if you want smaller. But there's a 31 and the 32, and then also there's like these letters afterwards, and you do have to watch out for these letters. So there's the difference between the 831 and the 832 is the 831 has a status pin that can, so this is the difference. The 831 has a push-pull output on the status, whereas the 832 only has a open drain pull down. Why does that matter? Because in this case, on this board, not every board that I use is Feathers, I don't use 2 LEDs. You can, on the 831 only, have 2 LEDs, one for charging and one for completed charging. And then it floats in the middle when there's like no battery detected. Whereas the 832, it only does in charging, like there's only the orange light. There is no green completed light. I don't like that you can have both. So I tend to use the 831 because I like to have the 2 LED option, and I only want to stock one part. Next, if we go down to the product identification, there's a lot of options that you'll see. So you'll see MCP 7831 dash 2CI, 2AD, 2DC. You do have to watch out because they're not the same. One, the regulation voltage. The T is just tape and wheel versus tube, I think. But the regulation voltage is that first digit. So if you get the 73831-3, or -4 or -5, that's going to have a battery pack voltage that's higher than 4.2 volts. Why would you ever get that? There are some batteries like that have anodes that are a little bit higher. They're not low cost, they're a little bit more expensive, but you see them in like, you know, some automotive projects and some, I've seen them in like skateboards and stuff. They have a slightly higher voltage due to the anode cathode chemistry. So they have a little bit more power you get out of them, total wattage, but you have to have, you cannot have the regulated voltage here be higher than the battery pack or you could damage it. You can't charge a 4.2 at 4.4. You can charge a 4.4 at 4.2, but you just like, you won't get all the power possible out of it. And second, there is the termination voltage versus the regulated voltage. And this has to do with when you first, if you have like a dead battery or very, very low battery, you sort of trickle charge it until it gets up to like 3.2, 3.3 volts. So like, you know, there's a little bit of like how much current versus, you know, the max amount of current, and then like how long do you do it for, whatever. You know, that's not as important. So I've sometimes used the AD instead of the AC because it's like, you know, it's like so closely related. But do check which one. And then there's two packages. There's the DFN and the OT. That said, the one I use the most, again, it's like kind of the standard issue is like, again, I like the 31 and 2 AC means 4.2 volts. AC is kind of like default termination current, trickle current, and it's in stock in DigiKeys. So let's just put on dark mode. Yeah. And it's in stock. And it's like, you know, pretty cheap, like 60 cents per. Some people are like, why don't you use like the really cheap, inexpensive, like 20-cent chips that are available that are like, you know, from like random ass companies? And the answer is you really don't want to like go cheap on your battery charger. I always use the genuine microchip parts because like I know that they have good engineers. The really inexpensive parts, it's just too risky. It's like if you don't charge a battery right, it's very bad for the battery, and you know it can be bad for the person handling the battery. So I recommend getting like a genuine part from DigiKey. So MCP 73831T to ACI. That's our pick of the week.
Where in the world is that part I need? The great search with DigiKey.
Thanks so much, everybody. We'll
Okay.
see you throughout the week. We have 3D Hangouts, JP's Workshop. We've got Show and Tell. We've got Ask an Engineer.
A lot of products.
Dive with Scott or Tim.
It was Scott this weekend.
Tune in all week long. We got new products and more. We'll see you next week.
Bye, everybody.